This is the example problem I want to do for you guys, and this is going to be, I'm going to apologize to blocks 2 and 3. This should have gone out earlier, but life got in the way. So we're going to go ahead and do an example problem. This is in your learning packet, so you need to flip to that page. It's past the vector note, so if you back up one page, you would see this whole thing about converting vectors and blah, blah, blah. And this is, again, the vodcast notes. So we're going to do a basic example problem that involves using vectors. And you've seen vectors on the plane. And what we're going to do is we're going to actually treat velocities as vectors. Now you've heard that term in when we were doing the buggy lab stuff, when we were doing the ramp lab stuff. Now we're going to be talking about velocity as vectors using this new definition of vectors, whether it be Cartesian or polar. So here's the idea. We're going to draw our axes using the compass. So that's obviously not 90 degrees, so let me try to draw that again. So we got, there, that's better. So what we're saying is that, normally we have y-axes and x-axes, and we're going to change this just a little bit to say north, south, east, and west. So we have a motorboat traveling 4 meters east, and it encounters a current traveling 3 meters per second north. So in other words, we're going to say that we have a boat going east at 4 meters per second, and then we're going to have this current that goes 3 meters per second north. And what we're going to also say is that we have this river that is 80 meters wide. So x naught is 0 and x final is 80. So that's sort of what we have going on. Now, first, we want to know the resultant velocity of the motorboat. So I'm going to write each of these velocities as the vector that it is. So first of all, the resultant velocity of the motorboat, I'm going to call that VR for V resultant. And then the east current, I'm going to call that velocity of the current, and then velocity of the boat will be this here. So normally the boat would go straight across, but this current kind of makes it go diagonally like that. And we want to actually find out what this V resultant is. So V of the motorboat, since it's traveling east, east is this direction, which is positive x. We have no part of the boat's speed north. And then we have the current going 3 meters per second north. So that's going to be 0 in the east-west direction and 3 meters north. Now here's a question. If this were going south, what would you do? If this were a 3 meter, so your question is, if this were 3.0 meters per second south, how would you write the V of the current? What would that be? It's a little something to think about. Now, to get the resultant vector, that's going to be V boat plus V current equals, add them the way you learned to add vectors. And so you're going to get 4, 3 as the resultant. Now, the resultant velocity. Now, if we wanted to know the speed is the magnitude. Get that word learned. I'm sick of you not knowing it. Get the word magnitude learned, which also means the length of the vector. That's 4 squared plus 3 squared, all under a square root. And that would be 5 meters per second. And of course, to get the angle, that would be the inverse tangent of 3 over 4, whatever that is. You can plug that in your calculator and find out. Now, it says if the width of the river is 80 meters wide, then how much time does it take the boat to travel to the shore? Well, that actually has to do with this speed here, the horizontal speed. So we have x final equals v naught t plus x naught. And actually, that's only the x component that we worry about. So that's going to be, we want to know how much time it takes. So we have 80 equals 4t plus 0, and that's going to give us t equals 20 seconds. And then for part C, we want to know the distance down the stream. Well, that has to do with this y speed here. So we have y final equals y naught x, sorry, v naught yt plus y naught. I don't know what that letter was. Just ignore that. It's v naught y times t plus the y naught. So that's going to be y final equals 3 times the 20 from above, since it takes 20 seconds, plus 0. So that ends up being 60 meters downstream. So that's kind of a basic introduction to how to do these problems. And then what you're going to do is we'll have you do this problem on the next page. And when you actually look at this, it's very, very, very similar. In fact, problems are virtually identical. So in fact, this might actually be your in-class quiz for whatever day I see you next, Thursday or Friday. So that's kind of a basic summary. So have fun with that video and good luck.